To anyone watching, happy not Pi Day. It is not Pi Day today, but it is Passover, and I thought I'd make a cool project. This project is going to be a combination, somewhere in between, um, coding trains peeking inside Pi and this awesome, super fast Pi search page. And the way it will work at the end, it won't look as complete as this, but it will have a text box and you will be able to type digits. And the way it works is basically you type digits, and our program is going to output the index in Pi where they occur. An important thing to note here: the first index is going to be 1, as in 3.14159, because you see here it says the 3 point is not counted. And this website does an amazing job of searching through it. I forget how many digits it's of Pi it stores. Okay, 200 million digits. And we're gonna actually be able to search. We're gonna search 100 million in this video, but you're gonna easily be able to download 100 billion, a trillion digits of Pi, and it will work. Let's just go to the How It Works tab, and we'll just see how they created theirs, because they did a really good job, and we're gonna take some of those. And they had some nice optimizations too. So as you can see, they just started off having a simple linear search. They just had a text file with Pi in it, and they went start to the end, and it was all done on the server. And when they found a match, they returned the index. Pi is really big, so next they moved to re-representing the file encoding as 2 digits per byte, which really decreased the time it took for them to read in the files, for them to search Pi. We're not going to do that. That's pretty technical, but we're going to do some other fun things. They also developed their own comparison, their own way of packing in digits 2 at a time and comparing them. That's too fancy for us too. But we are going to do this interesting thing that they did where when they implemented the interactive Pi search in 2013, you can see this client-side computation. Basically, it says that before they send a request to the server to find the index of Pi, they searched through the first 10,000 digits of Pi on the client side, so they didn't have to send unnecessary requests, and it would be super fast. This would also decrease, especially on Pi Day. It says they get so many requests. This would decrease a lot of the ones that come to the server. And you can actually see it in action if you open your network tab. That's also right click and then inspect and then click on network. This shows all the incoming and outgoing requests. And what you can see is, like, when you type, let's search for 999, that occurs at position 762, which is less than 10,000. And as you can see over here, no requests were sent to the server. But let's say I want to search for 999876. Requests were sent to the server because the index is past 10,000. We are going to implement that. It's going to be great. So let's just start by creating an index.html file. I just have a folder called Pi search. Simple HTML file, nothing special except for the p5.js library. This is just the CDN, Content Delivery Network. And p5.js is an amazing library. It's used for a lot of creative coding. You can draw on it. Helps with a lot of the canvas functions. It has lots of helper functions, and we're going to be using some of them today. And all of the p5.js code are going to go into the sketch.js file, and this is where all of our client code is going to go. So first, what we need to do is we're going to write a mini version of the Pi searcher that searches the first 10,000 digits on the client side. We're going to write that before we write our server. So what we need to do first, I guess, is load the 10,000 digits. So P5 uses a preload function for doing heavy endurance loads like this before you need to interact with it. when the page has loaded. So let's just say a raw, just like the coding train did, he did raw equals load strings. And then what we need to have is we need to have the URL of the 10,000 digits here. And I believe that this website has them. Yeah, okay, here it is. So if we just copy this URL here, that gives us the first 10,000 digits, and there's our request. Okay, let's create a global digits function, digits property here. And what we'll say is on setup, on setup, let's say digits equals raw 0, because if you've ever used p5.js, load strings, what that does is that takes a file. In this case, this is a file that's from a different server, but it takes a file and it will load the lines of the file into an array. And in this case, the first 10,000 digits, I believe it's just a single line. So the first element in the array is going to be pi. So let's console.log digits just to be sure, and we'll open this in Chrome. Let's open the developer tools. Okay, boom, there you go. There's our pi. So yeah, okay. And the next thing we're going to do is create a place for people to type in input. So they're going to be able to type in those digits just like they did here. And the way we're going to do that, we're just going to use pure p5.js. And no canvas. Actually, first we have to say no canvas, which basically tells p5.js we're not going to make a drawing app. Let's create a search box. And this search box is just going to be like an input box. And search box.input search, and I'll show you what that does in a bit. Index p equals create p searching. We'll just say searching. Okay. Okay, so what I just did here is I created a search box. Search box.input search basically means whenever someone types something into the search box, call this function. Okay, and index p is just, I just created a paragraph element here, and this is just going to be our output, so the index. Oh, and I forgot to instantiate these. These are going to be global too, because we want to call them from different functions. So search box and index p. Okay, perfect. Let's see how that looks. Okay, ooh. Search is not defined. Oh, that looks like a typo. Search. Create p. Okay, cool. And then when we type stuff in here, I can just show you. So let's say when search is called, we'll just console.log currently searching. And then I'll take the ellipse out of there. Okay, so when we type in anything, boom, console.log currently searching, I'll type in another thing. As you can see, that works. So next what we need to do is actually shouldn't be that hard. So in the search function, okay, so we have the digits of pi. We need to get the input that the user got. And so the way we do that is, I'm just going to call it num. We're just going to take the search box and get the value, which basically is whatever they typed in there. And the index of the search in pi isn't hard at all either. It's just digits.index of num. That's just a normal string function. and then we'll set indexp.html to be, how about found at index. And that's just basically indexp.html. I'm just setting the HTML of our paragraph tag. So let's save that, reload it, and how about let's search for 9. Okay, it looks like it's working. Oh, I forgot one thing. So because our pi, our first 10,000 digits of pi, comes with that 3 point at the beginning of pi, we have to subtract 1 from the index if we are counting 3.1, if we were counting that 1 to be 1, as in index should be 1 if we search for 1. So if we search for 1, oh, this is 2. Oh, right, we have to subtract 2. Wait a second. No, we should have to subtract 1. Okay, boom, there we go. So that looks like it's working currently, which is great, except for when we are searching for something that's not in the first 10,000 digits of pi, it returns a negative number. So what we want to do is, after it doesn't find our search query in the first 10,000 digits of pi, we want to send the request to the server and have the server search a much larger expanse of pi, you know, like a billion or a trillion digits of pi, which would be super cool. So, okay, so we have actually a version working right there, but let's create another one. So what we're going to do is we are going to create our server now. Let me open that. Let me create a folder called public and move our index and sketch into that public folder, because when we create our server, we're going to call those files from the public folder. So I'm just going to do npm init, and which just initiates a package.json file. I'm going to leave all of these empty by just pressing enter a bunch of times. And next I'm going to install Express. And Express is just an easy way to make servers in Node.js. So that's why I'm using it. It's just super easy. App.js. And let's create an Express app so that the server can do all of this pi calculating much faster. So Express equals require basically these first 2 lines just bring Express in and create an instance, and listen here is going to run our server on a specific port on local host when we run it from our computer. Okay, and one more thing. Okay, so we have to say express.use express.static public, and express.use basically allows you to use something called middleware. You can change the way queries come in. It's just a really easy way to do all of that stuff. But we're going to use it to so that when a user comes to our server, makes a request, it will automatically serve files from here, from the public folder. Okay, so let's test that static path by running our server. And so what we should see is our server should serve on the route files from the public folder, which should just be our client-side project that we just finished. So localhost 3000, and boom, we see that. Let's try to search through it. Okay, and it's working. Great. Let's test a route before we start making them, just to make sure they work. How about hey? And we'll see. So that's a get request to hey, request response. Had a brain fart there for a second. And rest.send. Okay, so this is a simple GET request. Let's restart our server and test it out. /hey. Boom. Oh, can I get hey? Oh, right. Oops, forgot the slash. Okay. Okay, hey back to you. That works. Great. Now, let's create our first search request. So the first thing to note when we're making our response to a request is that we need in the request that the client will send to the server some variable that they can send the number in, the search query. So let's say when they do /search, then that will be our URL, and we'll have it a URL like this. So they will do like a request to /search with a query parameter of q, which is equal to the digit that they're searching for. And you can actually see this in Google if you do a quick Google search. If you look up here, you can see google.com/search question mark, this weird question mark, q equals this. And that's called a query parameter, and it's just a way to send data in a URL. And so we're going to use that same way to send data in a URL. And the way you do that in Node.js, in Express, is with request.query. That gets the query object, which holds all of the queries, .q, because ours will be called .q. And then let's just do a quick test. Rest.send will say, your query was num. So let's test that out real quick. So we'll do a we got to restart that server. /search question mark q equals 382. Enter. Your query was 382. Question mark q equals that big mess, and there's a big mess right there. Okay, so that's working. Great. Now, let's see. Now we need a way to get the pi in the server side, right? Because remember I said that we're sending it to the server side so that it can search for the index in pi much faster than the client can. And the way we're going to do that is with just having a text file, because we don't want to store it in that fancy file encoding that the pi page used. So we're just going to import fs. And before we get too into this, we need to actually download the text file of pi. And we're just going to use, okay, so go to digits of pi, and let's download a million digits of pi. Let's download a million digits. Okay, here's a million digits, and we'll save it in our pi search. I'll just copy that name, and it's just gonna be a text file. Okay, great, cool. So we should see that right here. Cool. Okay, so there's a couple ways that we can do this. I'm going to do it the simple brute force type way. I'm just going to do it kind of like I did on the client side. Digits digits equals just some temporary value. And then let's just have, actually, I'm going to show you this way first. Let's do fs read file sync, and then the name of our file, .txt. So here's the naive thinking on this one. It'll just come into the program, okay? It will, I'm going to put this up at the top of the file. It will read this fast, and then we'll have everything good. That's not necessarily the case. Actually, here it will take a really long time to read all of these numbers, because this is such a ginormous file. And remember, I don't necessarily want the million. I only copied the million because that was what was on the website. I want to be able to later download a billion and a trillion digits of pi and have it be able to go through that really easy. And read file sync is not going to be the way that we're going to do that. It's just not efficient enough. We're going to use something called streams. And what a stream is, it's a way to, it's kind of like a buffer. It's a way to take data in pieces from a file or from some source and bring it in pieces rather than all at once. It's much more efficient, and it's actually faster in some cases, and it's just easier to think about. So we're going to create a stream using the same FS library, create read stream with that, with that file name pi1million.txt. And then we just have functions stream.on data, which just means when there's new data, when the stream gets new data, so it's just going to go through the whole file, and when it gets new data, we'll call that each piece of data a chunk. Digits plus equals chunk. And what this is going to do, it's going to populate our digits string with all of the data from pi1million. And so whenever you need, let's say you download pi1billion, pi1trillion, just change the name here, save it in your folder here, and it should go through that. And then we also need a stream.onEnd that takes another callback. No parameters there, and this is just gonna tell us, how about our delicious pie has finished loading. This will just tell us if it ends, just a gauge to see how long it will take. So let's run that just to see how long it takes. Oh, boom. That doesn't take any time. If you load a trillion digits, it'll probably take a couple seconds, but a couple seconds is not a long time, especially for a trillion digits. So we have that working, and we have all the digits populating our digits variable here. So next, what we need to do is actually create the response to our request, right? So when the user goes to search, so we get the user's query, and now we need to, I'm going to take that out real quick. Now we need to find the index. So let index equals digits dot index of num. I could create this right here. This is the line where I would create some fancy search function that makes it a lot faster, and I'm not going to do that right now, but that might be a cool exercise to do. So this is super simple. Let's just send the index is index, and that should work. Let's see. Okay, so let's try it. Okay, run that, go back here. Query is equal to, let's say, 9. Does that work? Okay. How about 4, 3, how about this big mess? I'll copy it and I'll cross-check it on the, oh, okay, that's not in it. Oh, okay. Okay, how about this? How about this mess? Okay, 64407. Let's cross-check it here. 64407. 644. Oh, I forgot to subtract 1. Boom. I can't forget that ever again. Just subtract 1. There we go. Okay, so it's working. It's pretty much working. And now let's see what else. What's okay? So we did the server. Ooh. I think it's time to implement it in our client side. Yeah, we got the server. Yeah, let's just let's implement it in the client side. So what we need to do here is make a request if it's not in the first 10,000 digits. And we know it's not in the first 10,000 digits when the index is -2, right? Because the string.index of returns -1 when it can't find it in the string, and we're subtracting 1 from that. So when it's -2, if index equals -2, if index equals -2, then we know that we have to send our request to the server to find it in a larger number of pi digits. And our URL, let's say our URL is going to be search with our query, remember, equaling num. And then we're just going to use the load JSON URL. And then this requires a callback. So I'll say, yeah, we'll just write our callback here. So data console.log data. Okay, so essentially load JSON takes URL, it does a GET request to this URL, and then the response will be put in the data. And we're just going to console.log it to see what kind of data we're working with here. Oh, actually, we didn't need to reload it, but that's fine. So let's go to the root directory and search for like this. Okay. How about something that's not in the top 10,000? Ooh. Uncaught in promise. Syntax error. Expected token H. JSON at position 1. Let's see. Oh. I forgot to return JSON in the server. So instead of sending back just this string right now, like we are, I'm going to do rest.json, which sends back JSON, and we're going to send back index. So it's going to be like an object. I'll send back an object where the index is the value of index right here, the index and just some syntactic sugar. We can just do that. Let's restart the server and reload. Okay. Boom. So it wasn't in the first 10,000 digits, so it sent it to the server, and it wasn't in the first 10,000 digits in the server either. So let's try 99999. Boom. Okay. And boom, there. So it's sending it to the server. We're getting that. Actually, let's go back to here. Let's look in the million digits of pi. And let's pick something that's like right up close to the end. So like that. Oh, that's a lot, but whatever. That. Oh. Let's see, what is wrong here? Oh, aha. In our sketch.js, what we need to do is we need to actually reassign the HTML data here. So let's say index p.html is going to be found at index data.index, and let's hope that's it. Okay, so there was an error that was happening where the server was sending back an index of -2, which means it didn't find anything when it should have found something in the first million digits of pi, and that was super annoying. But I found my error, and I forgot to put one equal sign right there. Really annoying. Really dumb error. So in search parameters, it's the name equals the value, and I forgot the equal sign. So, but now it should be working fine. So let's reload the page and let's search for my birthday, 2003. Okay, it found it at an index higher than 10,000. It's working great. And that's our project. Super easy, super fast to implement. It's great. And it's super extendable. I'm on the Pi search page. You can see that you can return the before and after digits of the number you found. You can change the digits into letters and search for your name. You can optimize the search algorithm. Instead of just having it index of, you can create your own. You can create a data structure that holds digits of pi so that you can search through them much quicker. You can create a hash. This is a good idea. You can create a hash where you store subsections of commonly searched for pieces of pi. It's kind of like dynamic programming, so the return is faster. There's just so much you can do. So much. So have a wonderful Passover. Have a wonderful coronavirus break. And I will see you in another coding challenge.